Our work presents an integrated development environment, or IDE, approach to bridging textual code and traditional schematics for electronics design. This video figure demonstrates the flow for building the example LED and microcontroller design from the paper's system description. To build the top-level system with the microcontroller and LED, we start with this empty code block. To add parts, we select an edit location in the code by positioning the caret, then search for parts in the library browser. We add this microcontroller, give it a name, and it shows up immediately on the block diagram with corresponding code. We then add an LED the same way. The hatched fill indicates this is a preview to avoid a recompilation delay. The red ports are unconnected but required. We can start a connect operation on the signal line, which shows type-compatible ports. Once made, connections also show up immediately on the block diagram with corresponding code. We then repeat with the ground line. Recompiling removes the hatched fills. Since the missing power source is giving us errors, we insert a barrel jack at the top of the class. This takes an output voltage parameter, which we specify as 3.3 volts in code. Then, we can connect the power line. Basic checks guard these edit actions. For example, the caret location is invalid here because the microcontroller is not yet defined. Moving the caret to after allows it to connect successfully, which again updates the diagram. We can also append to a prior connect statement by placing the caret inside, which we do here with the ground connection. Recompiling again produces a clean design. At any point, we can write arbitrary code, which preserves the full power and flexibility of the underlying hardware description language. Here, we array LEDs with a for loop, and recompiling yields the expected block diagram. If we were curious about the indicator LED circuit, we can click into one of them, which brings up a standard LED and resistor circuit. Mousing over the resistor brings up a summary tooltip, which shows the automatically derived constraint on resistance and the chosen part resistance. The IDE supports building subcircuits and components just like top-level designs, with ports added the same way as blocks. Here, we've already defined the ports for a magnetic sensor and need to associate a footprint and pinning. Like the block flow, we can search KiCad's footprint libraries for a SOT23 footprint, insert it into the code, and assign pins from a list of compatible ports. This ultimately generates a netlist, which can be imported into KiCad's board layout tool, as shown here, containing the discrete microcontroller with supporting components, barrel jack, LED array, and magnetic sensor. We hope that this IDE approach can provide a familiar and intuitive schematic interface while enabling the full power of a hardware description language.